minus 10.
Landing a man on the moon,
8,
returning in
7,
safety to the
6,
Earth.
main engine start.
Right away, Houston.
180 degrees to go to align with runway 15 as we watch a live view from the commander's point of view. The heads-up display. Altitude 23,000 feet. $21,000 feet.
Endeavor, on at the 90. Copy, on at the 90.
Altitude 18,000 feet. 2 minutes to touchdown at runway 15. 90 degrees left to go to align with the center of the runway. Endeavor's wings angled 35 degrees to the left as it continues around to the left turn.
Endeavor, Houston, roger.
This is a view now of runway 15 as Endeavor begins its final descent to the runway. A descent 19 times as steep as a commercial airliner's descent to the runway. 8,000 feet. This is a view from the ground of Endeavor. Altitude 6,000 feet. About 1 minute now to touchdown. $4,000 feet. 3,000 feet. 2,000 feet. This is a live view from on board of the runway. Landing gear down and locked. Touchdown. Main gear touchdown for Endeavor. Drag chute deployed. Nose gear touchdown. Endeavor rolling out, completing a 4.4 million mile mission that has spread the wings of the International Space Station.
Endeavor, Houston, roger, will stop. Outstanding job, welcome back.
that team is still out circling the Earth, and they will be there for several months. So we're going to try not to forget them over the holidays, and we'll keep them in our thoughts and prayers as they complete their mission. And I guess each of the crew members now will just make a brief remark and maybe talk about what the mission meant to them. Mike?
For me, the biggest technical challenge was the fly-around for the mission for me personally. And from my point of view, I think the funniest part was I was having to fight for window space, so that I could see the station to do the fly-around with everybody else trying to get a view and everybody else taking pictures out the back window. But eventually I was able to clear them out when we did the fly-around, and I'm here to tell you that the International Space Station is an awesome accomplishment, and it's going to get even more awesome. Looking out the window, it almost seems surreal to see this huge station, and it is huge, actually just floating against the blackness of space or against the blueness of the Earth was an almost unbelievable sight for us, and we were up there within 400 feet watching it, so it has to be even more unbelievable if you can't see it with your own eyes. But I'm here to tell you it's a great accomplishment, and I think the Americans can be proud, and the whole international community can be proud of what we've started and where it's going to go.
Bonjour Canada, bonjour tout le monde. La mission est finie. Nous avons accompli tous nos objectifs et puis on est de retour sur la Terre maintenant. Ça a été une mission vraiment qui est allée à la perfection et puis une mission dont je vais retenir des mémoires pour toute ma vie. J'ai été particulièrement ému par la visite qu'on a pu faire à l'équipage de la station Alpha. Pour moi, c'était une première de pouvoir visiter une station qui était habitée. C'est cette mémoire-là que je vais retenir le plus longtemps. Apart from the natural beauty of the station, it really is a beautiful sight to behold. I think that for me, what will remain with me for the longest time in my memory was the opportunity to visit the Expedition 1 crew on board Alpha. That was the first time experience for me to visit an inhabited station. The mission has come and gone now. It's been 2 years since some of us started to train for it, and at times in the past it looked like it would keep slipping to the right, but then suddenly it began to accelerate very quickly, a little bit like coming in after the deorbit burn, and it's already over. But I think that we all feel the satisfaction of having participated in a mission that went well.
I'll just use English if that's okay. Most satisfying part of the mission for me, of course, was the EVAs. The first two EVAs we had trained for, Carlos and I had been working on for 3.5 years, and as you could probably tell, we had most of the procedures memorized, and it was a chance for us to do what we had trained in the water for so many hours, to finally get out onto the real hardware and actually do it and answer some of the questions that we had on how these mechanisms were really going to work in space. And that was very satisfying. The third EVA was icing on the cake, particularly with the problem with the tensioning, and able to solve that problem, because we know we made a lot of people on the ground happy by successfully completing that task, and as well as of course what it meant to the station to be full up on the solar arrays. Running a close second, however, was the time I spent in Alpha with the station crew. I knew Shep pretty well already, and I knew Sergei a little bit, but I didn't know Yuri at all. I spent a lot of time with him. Spent almost all of my waking hours and minutes in station, helping them and doing things with them, and that was very, very satisfying to get a flavor of what life was like aboard the station and what those three men are like.
Well, I guess I knew I shouldn't have sat on the end. You guys have already stolen all the good material. But I do want to add that I agree with exactly what Joe said, especially. But the sense of finishing the work of the literally hundreds of people that we've met over the last 3.5 years, and the thousands that we know have worked on this hardware, when we did the fly around and actually seeing the beauty of the station with those arrays spread, was absolutely amazing. I'd seen them up close as you probably saw from some of those rocky images coming down from my helmet camera. But when you see it up close, it's a little different than backing away and looking at the whole station as a whole and how much it had grown just from the week that we had been there, and the culmination of the work in some people's lives, over a decade, if not more, of time put into that, and we've been able to basically finish off the work that they had set rolling, and be part of that and see what it looked like was just absolutely fantastic.
All right, thank you, and we'll open it now to questions and answers. Please give your name and affiliation with the mic when the microphone comes to you. Start here in the front with Marcia.
Marcia Dunn, Associated Press, for any or all of you. Was there ever a moment or moments aboard the shuttle where you really wondered whether you were going to pull this off? Whether there was like a little moment where you wondered if everything was going to go okay in the end?
I think up until...
Well,
Right from the very beginning.
Yeah. I had a really good way of describing it. When we finished EVA 1, that was a major high for me. It was my first time being outside, working outside. We'd face challenges out there with other mechanisms as well, and we'd overcome them. Everything had, from an EVA perspective, it had gone very well. So personally, Joe and I were on a very high, but we also had that realization that, there's a potential out there that we could have to jettison one of those arrays, and that was just something that I didn't even want to accept. But I also knew that somebody was going to find a way to fix that thing. So it was just a really tough night emotionally.
Yeah, I had a moment, and I was outside when I had this moment, but when I looked at pin number 3 on the blanket box, it did not pop, and we had indications that that all the pins must have been good, or thought they were good. And I looked at pin 3, and it was not popped, and pin 3 is one of those that needs to be popped. And I looked at that, and I said, no, I disagree with your analysis that we can go ahead and deploy this array because this pin is not out. And I knew what that meant. And we have a way to remedy that situation with a special tool that was built for that task, but there was a whole lot of overhead associated with that. It would have changed EVA 2's timeline completely, and then subsequently then EVA 3. And so I looked at that, my heart sank just a little bit, and then the first thing they tried, of course, worked, and so praise God, for that, because it was really going to mess things up.
And I don't know if you really had time in orbit, even after undocking, to really just calm down and relax. I mean, did you have any time, or did that time have to wait until last night, where you really felt like the weight was off all your shoulders?
I think after we completed the fly round, the time between the end of the fly round and the start of the preparations for deorbit the pace of that day and a half was much more relaxed than the previous days. We were actually able to get to the window and use some of our film, which we had used very little of in the previous days. But we needed that time because we needed to get the cabin stowed, and as you know, turning the orbiter from what you consider a spacecraft now into its quote airplane mode or re-entry mode involves a lot of work, and Joe and Carlos had a great plan. We were well ahead of that timeline all the way through because we didn't just let up. I mean, we tried to stay ahead, and deorbit day was actually pretty easy for us because we were constantly ahead of the timeline. And of my 3 missions, it was the best deorbit day that I've experienced.
Sue?
Sue Butler here. I probably shouldn't bother you with this now, but since all went well, but you learned about the booster problem when you got back, I understand. And did you feel that maybe you had a close call when you learned that the booster pyrotechnics didn't work as advertised, and when you remember that there was a pin on the pad on a previous mission, and there was a loose water pipe, and 2 of the jets a chip, and there's water damage, and all these little things add up. Did you feel you had a close call, and do you feel maybe the workers have to pay more attention to what they are doing?
Well, that's a lot of questions. Let me try to address them. I actually learned about I first heard about the problem with the NSI during the press conference, the joint press conference on board the station. I hadn't read or heard anything previously. I still haven't read anything or seen anything official on the details other than just what I've heard from talking to people. My answer during that press conference is pretty much the same as it is now. Before I comment on any technical issues, I'd prefer to read the report, but I know that the NASA Standard Initiator is a very reliable mechanism. It undergoes very stringent testing, but nothing in life is perfect. And when you have a critical system, that's why you must build in redundancy. We do that with hardware. We do it on board the shuttle when we're performing critical tasks. We never let one person do it without somebody else as a backup. So, you'd never like to see failures, but that's why you design a system, a critical system with redundancy. And just like advertised, the redundant system worked and everything was fine.
But how about the close call? Did you ever feel, when you came back, said, whew, that was another lucky
No,
one?
I never really felt that way. Booster SEP was nominal from our perspective. The backup system worked just as advertised and performed exactly the function it was supposed to. So I didn't feel like we had a close call. But.
No, and I think as a testament to how well the workers do down here is we did not have on board, on orbit, a single orbiter problem that involved any of our time, to baby the orbiter, if you will. It was an awesome machine, and it did everything we asked of it. And that had, if there had been anything that we had to chase while we were on orbit, it would have had a huge impact on our ability to perform and accomplish the mission objectives. And we didn't have any of those. I mean, it worked flawlessly the whole time. All the systems worked exactly like they're supposed to work. And we, from our point of view, it was in the background. It wasn't something we were chasing. And so I think that's a testament to how well they process the vehicle. And I think the other thing is these things are coming out, and you want people, to bring that stuff to the front and to solve the issue, and they're doing it. Anything that comes up is coming right up to the front, and they're going after it aggressively, and they're solving it. And you got to expect that in any program that's as technical as the Space Shuttle and the International Space Station.
Phil?
Phil John Earth is for Bloomer. You mentioned the fly-arounds, and while we were watching it, there was a couple of references in the air to ground that I've only been able to piece together afterwards. Apparently, this was a lot more challenging for you than previous fly-arounds because of the problems with the wind decom. What happened there? How much less information did you have? And was it more difficult to fly a perfect circle without RPOP helping you out?
Well, as you know, RPOP is a machine it's a computer program that we run, and it incorporates information from the data system on board the orbiter, and from that it draws a big picture up on our laptop of where we are relative to the International Space Station. For some reason, it wasn't pumping that information. It has to go through one computer to get to another in order to give us that picture, and for some reason it wasn't doing that. In order to do a fly-around, you need basically two pieces of information. You need to know how far you are from the International Space Station, and you also need to know whether you're closing or opening from the International Space Station. And those are the variables that I control. On board the shuttle, like with anything else, there's redundancy built in. And in this case, we still had a system that we can use that uses lasers that goes out and measures the range rate, or how fast I'm closing or opening from the orbiter. And Carlos had a handheld laser on board where he could measure the range. The handheld laser also can measure the range rate, the closure or opening from the International Space Station. So given those pieces of information, I could still fly and do the fly around. I did it a little bit more cautiously than I would have done if I'd had more information. In other words, I was out at 500 feet as opposed to coming into 400 feet to allow for any error that might have occur. but it was very doable, and it was kind of ironic. It's something that we practiced for, and it's interesting that the last fly-around I did on the simulators before I left Earth at Johnson Space Center was exactly this profile. I did it without basically the RPOP and using handheld laser and looking out the COAS, and so it was something we had trained for, and it worked out extremely well.
Was it also because of Windows configuration problems?
I don't know.
That computer had problems. Carlos had problems during the rendezvous. It dropped off.
Yeah, this computer caused a lot of problems. I think it tended to overheat, but we'll find out later on. There was the files had worked properly earlier in the flight. There had been some potential problems with the computer, and just did not want to work that morning. I tried A, B, C, all the way down to Z that morning very quickly. None of them seemed to work, so finally I just said, we're dropping it, and grabbed the laser and started shooting the station.
Steve?
Steve Seislaw, Florida today. For the commander, since you've had prior experience on Mir, I'm wondering if you can compare the atmosphere in Mir versus that on this station. How was the aroma? Was it more cramped than you expected? How was it?
Well, it was different. I had a different sense of going in Alpha than I did going into Mir, and I guess part of that was because when we went to Mir, we felt like guests. Although we were, delivering supplies and assisting the cosmonauts as much as we could in their duties, I think when we went into Alpha, we felt more like teammates in the activities scheduled for that day. So that was one big difference. Obviously, Mir had been up a lot longer, so it had accumulated many more items on board, so it was a little bit more cluttered. The way Shep is running the station reminds me very much of a Navy ship. He realizes that everything must be put away, and you have to keep things very orderly. He has a plan of the day he runs. So I was very impressed with the way the crew was conducting themselves, and I think the biggest difference was I felt like I was part of their team rather than just a visitor.
And for Joe, you said prior to the flight that you'd be obviously able to compare the two spacewalking tasks a lot better after this mission. So if you could compare working on the outside of the station to working on the Hubble.
So I guess I have to answer that question now, don't I? Finally. And you're comparing Hubble tasks versus station tasks. Hubble tasks, I think, require a little bit more fine hand detail and dexterity with your fingers. Some of the connectors, all of the connectors basically on Hubble are smaller than just about any connector on a station. You're not doing a lot of real strenuous work with your body on Hubble tasks, but your hands take a lot of abuse. On the station, you're moving around a lot. Carlos and I translated 80, 90 feet and didn't even think anything of it. So it's a lot of movement. Now, it's not necessarily strenuous, but it is something that you really need to mind when you're moving that far. We carry bigger objects on station missions or station EVAs, and all of the connectors are bigger and require a little bit more physical activity. So I would say that in general, a Hubble EVA is going to require more hand-intensive activity and probably fatigue your hands a little bit more, whereas the station missions is an all-over body fatigue. Now, neither one of us got extremely tired. I think part of the reason is because we spent a lot of time preparing physically. Spent a lot of time at the gym, and Carlos is a lot stronger than I am, in spite of what it looked like on the hatch. I'm just glad he broke it loose for me. But we were physically prepared, and the tail end of that 7-hour EVA, I said, I'm not tired. I wasn't tired.
Jerry? Jerry Hansen from Time Magazine, right off the bat, super cyclonic congratulations to you guys. You really gave us a real thrill. But as a corollary to my
how did the specially designed tools work for you guys? Because you were using, and you cited one special design tool. Are these ergonomically fitted to you, not as individuals, but as to human beings out there grappling with nuts and bolts in space?
The pistol grip tool was the tool that we used the most for fasteners. Pistol grip tool. You think of it like a big power screwdriver that we put sockets on it, and we use that all over the place. And that tool just worked fantastic. In the water, it's big and bulky and tends to fall to the bottom if you're not gripping it right. But out there, it worked just great. Joe used a torque multiplier quite a bit out there, and I guess you didn't have any issues with that. A lot easier than in the water, I imagine.
Yeah, it's a great tool.
Torque multiplier is.
Well, since I used it, I'll talk about
Yes.
it. That torque multiplier is a cylindrical tool. It's probably 8 inches or so long and 4 inches in diameter, and it multiplies the input torque by a factor of 5.
Hydraulic?
No, it's strictly mechanical. Mechanical advantage. So you attach the torque multiplier to either a round or a square fitting, and then there's a socket inside the torque multiplier that engages the fastener head, the bolt head, inside of the conical or square fitting, and then you insert the pistol grip tool, which incidentally was designed initially for Hubble missions and stations. So that's a great tool. We want to use it, and so now everybody uses it. And you insert the 3/4 or 3/8" drive into the end of the torque multiplier, and any input torque that you give then is multiplied by a factor of 5, and you use that to break any torques that are higher than 25 foot-pounds.
That's fascinating. It really is. A lot of people will be heading for the Stanley toolbox right now around the country.
Well, the torque multiplier is not a good tool to use on the ground because it weighs a ton.
Yeah. I read you. But the consensus here is that these tools worked. And will you have any specific recommendations when you debrief as to any enhancement of the force multiplier or whatever? Will you have any specific recommendations to the crew at NASA?
No, as far as tools concerned.
Yeah. Actually, one tool we didn't mention that we both raved about at the time was the body restraint tether, or BRT, and that was something that rides on our hip, and it's a stack of balls that are strung together, and it's got a clamp on the end of it, and we would just use it to clamp our bodies onto handrails wherever we were, and it would keep our bodies fairly rigidly attached to the structure. And that particular tool frees up both hands to use. Now you don't have to use a hand to hold yourself still. And that was a fantastic tool. I'm going to recommend that everybody use that a lot, and was just, I don't know, I couldn't say more good words about that thing.
We became instant BRT fans.
Yes.
All right, Mike?
Mike Catters with the Orlando Sentinel. Sort of a big picture follow-up question to that for anybody who'd like to answer it. There's going to be other solar arrays that are going to follow P6 up, and based on your experience deploying P6 and the challenges you guys faced and overcame, what sort of changes do you think you might recommend for future crews who are deploying arrays?
Well, I think the program will take a hard look at the lubricant that they're using between the panels and decide whether or not that needs to be adjusted on the future segments. Obviously, the ground team did a super job in less than 24 hours of coming up with a procedure, or at least a starting point to work from that allowed us to get the second array out without any problem on the tension cables. That procedure was sort of modified real time. As you may remember, it didn't work exactly like they thought, and we were able to modify it and actually get the panels unstuck. My recommendation would be that if it is possible to go back in and make some changes to that lubricant, that they probably ought to look at whether or not that could be done. I think you could use that same procedure that we did for the future arrays, but we had a really good view of what was going on, and when you start building the truss, I'm not sure what kind of, you're going to be looking through different cameras, and it might become more difficult. Joe, do you have any anything to add?
I would agree with that, and I called down on the radio after the array was out and said it was really tense in the cockpit, and that was, kind of a smart remark, but it was true. I mean, we were really working that hard and looking at, everybody had a job to do, and they were doing, we'd confer as a group in the cockpit with a recommendation on what we thought we ought to be doing next, and then we'd communicate it to the ground. So we were all working together as a team, and this was exciting. I mean, this was really neat space stuff. And we were working together with the group on the ground to come up with the best solution, and it worked.
And for Mark, before the flight, you had mentioned that this might be your last flight, and you were going to try and savor the moment, stop and smell the roses, I guess, a little bit more.
We did.
This flight. Tell me a little about what you did differently on this flight, and if you've thought any more about whether this would be your last mission.
Well, yes, I have thought about it, and it is my last mission. And the great thing about after undocking was that we no longer had same restrictions on orbit or attitude, so we were actually able to go minus ZLV, which means cargo bay to Earth. And of course, when we looked out the overhead windows now, we didn't have a big piece of space station in front of us, so we were actually looking straight at the Earth. And some of us were a little disappointed when we saw our original sort of orbital map that we were going to be in daylight always in the southern hemisphere and at nighttime in the northern. But we decided to have a crack at looking out the window at nighttime. And for me, it was very, very nice to see Canada under moonlight with sort of a dusting of snow on it. So it was actually quite bright, and it brought out a lot of detail that you might not really see quite as easily even in daytime. So we did a couple of passes over the United States and Canada, and I think those memories are definitely going to be engraved in my mind, because I've never seen that kind of view. And I did take some time to sort of just sit there and look out the window at the great big Pacific Ocean that you go over forever, and think about what this was all about, this whole experience, and so that I could retain that. So although it was all rushed a little bit in the last 2 days, I think I accomplished my objective.
All right, Todd, we're running a little short on time, so a couple of short questions if you can.
Todd Halverson of Space.com. For Joe Tanner, I wonder if you could just tell us what you were feeling when you mounted that evergreen on top of the P6. That was quite a nice touch.
It was a tremendous feeling of satisfaction for the whole team that had made that all possible. And we just felt privileged to be the ones to get the top out the building. We thought it was an appropriate thing to do, and that was just a very satisfying moment. Satisfaction, I think, is the best way to describe my emotion at that time and right now. Very satisfied.
And for Mark Garneau, just a quick follow on Mike's question. I was wondering what you actually felt like when you woke up this morning, thinking that, well, here you are, you're on the ground, and your last mission is history.
I don't think I've come to terms with it quite yet. It's still all a little bit confused in my mind. I think I felt heavy this morning, that's for sure. Couldn't just sort of lightly push my fingers on the bed and float up out of it. But there are some great advantages to gravity, and I'm glad to be back in gravity. And I think I feel personally that I've done everything I wanted to do. So I'm feeling satisfied, as Joe said.
All right, thank you very much. The astronauts have to catch an airplane, so that will conclude our press briefing. Thank you very much.